Okay, so today's lesson is about volume of prisms, and we've talked a little bit about prisms. Prisms are three-dimensional figures. There are two basic kinds of prisms. So if we look down here, we've got these two basic types. Take a moment, look at those, see if you recall which of those is which. One of those is a triangular prism, and one of those is a rectangular prism. So, hopefully you remembered, this one is the rectangular prism, and it's called a rectangular prism because its base is a rectangle. And not surprisingly, this is the triangular prism, and it's the same reason. It's because its base is a triangle. So we name the kind of prism based on the base, depending on the base. So here's our real world link. Suppose you observe the camping tents from directly above. What shape would you see? And we've talked about this before. We've talked about the fact that the shape you would see is a rectangle. If you look directly down on it, rectangle, maybe with a line right there, and that line is this right here, this top of the tent. What formula would you use to find the area of the figure that you saw? Well, anytime you're finding area of rectangles, you're doing length times width. And as we move further along in math, we get rid of that times sign completely, and we just write it as LW. And we know that if it's LW, it means L times W. Look at this guy. Look at this guy. He's not sure exactly what he's saying. All right, let's move on. So now we're going to look at how you find the volume of a rectangular prism. So if you think about the area of a rectangle, you find the area of a rectangle. If I had this rectangle, I would find its area by multiplying the length times the width. So to get the volume of this, and volume is how much something can hold. If you look right here at this definition, volume is all about how much something can hold. It's like packing a box. If you looked at the volume of a box, if you're Amazon and you're shipping stuff, you know, Wilmarth buys something, you want to pick a box that fits well into. Hopefully not too big a box. Not a box that you have to put a whole bunch of that packing bubble stuff into. So volume is how much something can contain. When you look at a milk carton, it's how much milk fits in the carton. When you look at a wheelbarrow, you know, if you're filling a wheelbarrow with dirt, it's how much dirt fits in the wheelbarrow. So when we're doing volume, we're always talking about three-dimensional figures, and to get the volume, we multiply the base or the length times the width, like we did to get that, to get the area of the rectangle, and then we just add the height, or we don't add it, we multiply by the height. So you can see the formula here written two ways: length times width times height, or you can think of it as find the base, the area of the base, and then go ahead and multiply by the height. So here's a thing to remember. Put this over in your work zone. Area, two-dimensional. Because it's two-dimensional, we only multiply two things together. We only multiply length times width. Volume, three-dimensional. And since it's three-dimensional, we have to multiply three things. We have to multiply the length times the width times the height. So when you're looking at a three-dimensional object, you're multiplying three things together. By the way, you might be thinking, well, what about something that's one-dimensional? So here's something that's one-dimensional. A line is one-dimensional. And since it's one-dimensional, we don't multiply anything together. We just take the length of the line. So we just, for line, we just have length. So one-dimensional objects, just length. Two-dimensional objects, length times width. Three-dimensional objects, length times width times height. All right, so then they show you a picture of volume. They show you these little cubes. Volume is always measured in cubic units, like cubic centimeters. So whenever you're measuring volume, you're measuring in cubic units, like cubic centimeters or cubic inches. Here are the instructions for an example. So find the volume of this prism, 5 times 4 times 3. So go ahead, do this got it problem. Multiply that out. You have a calculator built into your Chromebook, so grab that calculator and use it if you need to, or do it by hand if you want to. Go ahead and do that. All right, so you should have multiplied 3 times 9.5 times 5. Order doesn't matter. 3 times 9.5. Now, if you did the base first, then you'd have 9.5 times 5 times 3. I would reorganize this as 3 times 5 times 9.5. And the reason I would is I can do the 3 times 5 without needing any tools, without having to write any long steps. So I do that, and the more times I can accurately do it in my head, the fewer buttons I'm pushing on a calculator. Number one, it goes a little bit faster, but number two, I don't have the chance of pushing the wrong thing on the calculator. So multiply that out, and you should have had 142.5, and then since it's in meters, this would be square meters. So you could put, if you had little tiny meter blocks, little tiny meter blocks, right? You could put 142.5 of those little tiny meter blocks inside that rectangle. All right, a rectangular prism, excuse me. Okay, so now we're going to look at finding the volume of a rectangular, of a triangular prism. So because we use the same term for several things here, notice they've talked about the height, but you're thinking back to, wait a minute, when I was finding area of a triangle, you gave me something like this, and you said that was the base and that was the height. Now you're telling me this is the height? Yeah, that's this note that they write you right here that would be good to keep track of. So since we use the same term for a couple of things here, which can get confusing, what we suggest is that anytime you're finding the volume of a triangular prism, really think about it as two things. Just find the area of this. Find that area, and then whatever that area is, area of triangle, whatever that area is, multiply it by that height. So really break it into two problems. When you're doing a rectangular prism, if we go back and look at rectangular prism, right, on this one, we can just think of it as, you know, multiply, multiply, multiply. Just multiply those three things together. Piece of cake. Just to save confusion when you're doing a triangular prism, get the area of the triangle and then do the height. Think of it as two separate parts of the bigger problem. So, same idea. You're putting in little tiny cubes, little tiny cubic units. Here's an example. So, notice they broke this out. They did the 6 times the 8, and they got half of that. We would have the same thing. You know, we've talked about it a little bit differently. We've talked about the 6 times the 8 divided by 2. That's the same as multiplying by a half. They got that answer, so 6 times 8 is 48. Divided by 2, that's 24. They got the 24 for this area, and then they took the 24 and multiplied it by the 9. So breaking it into two separate problems, breaking it into this work to get that amount, to get the area of that triangle, and then once you have that, multiply by the height. Now you might say to yourself, wait a minute, that's not a height, that's a length. Try not to get too caught up in exactly what to call it. It's the amount going away from the triangle. And what it's doing is it's building a whole bunch of little triangles. It's building, you know, every foot there's another triangle going along. All right, so go ahead, pause the video, find the volume of that triangular prism, and then come back on and we'll discuss it together. All right, here we go. So we have two different problems we're solving here. Our first problem is going to be to get the area of this triangle. So we know that it has a base of 4, a height of 5, divided by 2, so that's 20, divided by 2, which is 10. That would be 10 inches squared. That's what we've done so far. Now we're going to take that 10 inches squared and we're going to multiply it. Get rid of those extra little things. We're going to multiply it by this height or length. We're going to multiply it by that, and that will give us the overall volume, which is 70 inches cubed. Okay, so rewind that. If that didn't quite make sense, go ahead and feel free to rewind it, and then we'll move on. Okay, before we move to the next page, let's go back a page real quickly, because I realized as I was writing for the triangle that it was inches cubed. I realized I made a mistake back here. Back here, when I wrote my final answer, I wrote that as meters squared, and I should not have written that as meters squared. Some of you probably caught that. I should have written it as meters cubed. So when I find my first part, when I got this 15, that would have been squared. But by the time I got to the whole thing, that would have been cubic units. All right, so I wanted to clear that up so we didn't have any confusion. Let us jump ahead, and we've got this great example with some lunch boxes. Ooh. So now, what they're asking us with these wonderful lunch boxes, which lunchbox holds the most food or holds more food? So really what they're saying is, which has the greatest volume? Go ahead and write that in. Which has the greatest volume? So then they go through and they run through it, and they do the length, width, and height of the first one. These are both rectangular prisms. And again, the nice thing about rectangular prisms is you can just multiply all the numbers together. You don't need to worry about finding the area of a part like you do with a triangular prism. And when you do that, you find that lunchbox B ends up holding 285 cubic inches of food. Lunchbox A only holds 281.25 cubic inches of food. So now you're ready for some guided practice problems. Let's go ahead and have you work those two problems. So pause the video, work those two problems out, and then we will come back together. So you should have worked these two problems out. Now please don't just listen to the video and wait for me to solve it. Actually do the problems. Take a shot at them, all right? So on this first one, I have a rectangular prism, which means I know that I am going to multiply the 11 times the 5 times the 4. You can do this in any order you want to. Do it in the order that I just wrote it. So 11 times 5 is 55 times 4. Now that 55 would be the area of this base. So there goes the crazy pen again. Let's try that again. Would be the area of this base. Oh, no crazy pen. Which would be 55 square inches. And then we would multiply that by the 4 inches. And that would give us 220 cubic inches. Now, I could, you might say, well, what if I did it in a different order? What if I did the 4 times the 11 times the 5? What if I decided that the first one I'm going to find is this one? I'm going to get that side first. Well, that'd be fine. You'd get 4 times 11 would be 44 square inches of area for that. And then you'd multiply by this 5-inch depth, and you would still get 220 cubic inches. So the order you multiply the three numbers together does not matter. Number 2. So on problem number 2, we have a triangular prism, and we know that the first thing we're going to do is we're going to find the area of that. We're going to multiply the 3 times the 7 and divide it by 2, which is 21 divided by 2, which is 11.5. 20 plus another half. Oops, excuse me, it's 10.5. My mistake. 10.5. Then we're going to take that 10.5, which is the area of that triangle. So if I take the 10.5, that's 10.5 square yards, and I multiply it by 6 more yards, I'm going to get 63 cubic yards. So this would be 63 cubic yards because my last multiplication was right here. This 6 yards, I multiplied it by that amount, and I ended up with 63. All right, one more problem for you to try. Go ahead and do number 3, where you're comparing those two cabinets. So pause the video, do number 3, and then come on back to us. All right, I've grabbed my calculator here. So I've got 2 cabinets. We're going to call them cabinet 1. I'm going to be super creative about this. So for cabinet 1, we're multiplying 3 times 2.5 times 5. Well, I'm going to multiply the 3 times 5 first. I'm going to get 15, because again, I can do that quickly in my head, times 2.5. And 15 times 2.5, 15 times 2.5 gives me 37.5. So cabinet 1 is 37.5 cubic feet. Cabinet 2 the dimensions. Whenever we're talking about this type of stuff, we're talking about dimensions. The dimensions of cabinet 2 are 4 feet by 3.5 by 4.5. So 4 times 3.5 gives me 14. That would be 14 square feet. That would be a base or a side, the top, the end, whatever it might be, times 4.5. So 14 times 4.5. And that's going to give me 63 cubic feet. And since 63 is greater than 37.5, I know that cabinet number 2, the second cabinet, would be the one that has the greater volume. All right, so there you go. Watch any part of this over again if you need to. You've got some homework problems to work on to help yourself practice this and make sure you understand it. Please do those problems, and then be sure you come back to class with any questions.